I welcome you all to the Spark Research YouTube channel. This is Dr. Vijendra, Assistant Professor in the Department of EC. So this is the another session of the series Analog and Digital Communication. And in this session, we are going to take the questions which has asked in GATE 2023, which particularly belongs to our first two units, right? So let's see. So here is the overview of this gate. Like normally, if you will check the syllabus of your gate, then it includes the analog communication where amplitude modulation, demodulation, and angle modulation, demodulation are there, right? And along with the transmitter and receiver. So some questions definitely are coming from this analog communication part. So in this first two units, we have covered these analog communication particularly topic. Right? Sure. Let's take the question now. So question number 27. Let MT be a strictly band limited signal with bandwidth W, B and energy E. Assuming omega naught is equal to 10 times of B, the energy in the signal MT cos omega T is. So MT is given that this is the message signals which is band limited. Band limited means having fixed bandwidth, and bandwidth is B, and energy is also given E, right, for MT. Now asking the question, what will be the energy of this signal, that is modulated signal, that is MT cos omega naught T. So since omega naught is already given that the 10 times of B, so this is acts like the carrier wave, right? So we have to find out the energy of this modulated. So, as per answer key, the provided the answer B is correct, that is E by 2, right? So, let's see. So, first of all, how can we find out the energy? So, energy can be found of m of t, like integration over minus infinity to infinity mt whole square dt. So, this energy we can calculate in the time domain. So already it is given this minus infinity to infinity mt whole square t dt equal to E. It has been given in the question only. Now asking that what will be the energy for this modulated wave, that is mt cos omega t, right? So for easy calculations we can directly calculate in the energy, but for easy calculations we can also convert into the frequency domain, and as per the Parseval's theorem, this theorem states that the energy in the time domain is equal to the energy in the frequency domain. So it is very easy to convert this into the frequency domain, right? And then we can find out. So Em can be minus infinity to infinity and mff whole square df, right? So we can convert and then we can find out the energy. So for this, for m of t, for integration of this means for m of f, it has been given, that is E, right? So this is your band limited m of t signal, and correspondingly this is your m of f or m of omega, and that have the energy is total energy is E already given. So E is equal to minus b to b m of omega whole square d omega. This one is already given in our question, right? And so we have to calculate now energy for the mt and cos omega t. So this is the masses in time domain and frequency domain. Now we have to calculate for the modulated signal, right? So here is the our modulated signal, that is xt. Xt is equal to mt and cos omega naught t. So let's convert into the frequency domain. So we can break this cosine function into the exponential, that is half of e to the power j omega t and plus of e to the power minus j omega t. You can use this Euler's formula, right? And then we can multiply. Now we can write the xt is equal to this and into the mt, just we will multiply this thing into the m of t, right? And so here what will happen, like xt here, if you will check, then using the frequency domain interpretation, we can write x of omega, here it should be x of omega will be half of m of now omega minus omega naught, frequency shifting property, and half of omega plus omega naught, right? So now we got it, and now if we wanted to get the integration over this, then this will be half of the half of m of then this omega minus omega naught square. So that will be the energy, right? So already we know this is the energy, and E is already given in our question. So in terms of the amplitude now only this will with m of omega, it has been given that is the integration of m of omega d of omega is equal to your energy E. So half square that is equal to 1 by 4 into E for this portion, and for this portion again it will same. So 1 by 4 into E plus 1 by 4 into E. So total E will be E by 2. Right. So option B is correct. Okay, let's take one more question. So in this question, let a frequency modulated FM signal xt is given, a cos, then angle is given, that is omega ct and plus kf minus infinity to t and m of lambda d lambda, right? You can use m of t dt, right, for simplicity, where mt is message signal of bandwidth W, right? So here it should be m of t only minus infinity to t. So there is question misprint only. Okay, in gate itself, not from my side. So it is passed through a non-linear system with output yt is equal to 2xt plus 5 of x of t whole square. So this is the one non-linear system. So their output will be this. Now let pt denote the FM bandwidth, right? So BT is the bandwidth of your frequency modulated signal. So the minimum value of omega C required to recover xt from y of t. So this is your y of t, and now you have to recover the message signal, right? So the minimum value of omega C that required to recover the xt. So how will you do, right? So in as per answer key provided, your answer B should be correct. That is twice of BT by BT plus W. Right. So let's see. So FM signal is given, that is x of t, and the x of a square actually y of t. If we look into that, then this is the combination of 2xt and x square t, right? So in order to not overlap, like the first harmonic, that is the DC component, and the second harmonic must not overlap. Otherwise, what will happen? So in that case, otherwise, if it will overlap, in that case, it will be very difficult to reconstruct this x of t. So in that case, we cannot reconstruct. So if you will solve, then you will get that the minimum, that is omega c, must be greater than thrice of Vt by 2. So let's see the detailed calculation. Before these calculations, you can also visualize this, like spectrum is given for x of t and x square t, and so here you can check in order to not overlap, both should not touch, right? Means the frequency must be the gap may be the zero, but minimum it should be zero. Otherwise, both will overlap. Then the xt and x square t, and then in that case it will be impossible to reconstruct. Means how will you decide which signal belongs to the this particular frequency? Because in the same frequency, both messages, both information will be there. So that is why we cannot reconstruct. So how to calculate here? Xt is given, that is a cos omega ct plus kf, and then minus infinity to t mt dt, right? So this is already given here, and so the frequency range for this your omega c. So this is actually angle modulation, if you'll remember, right? So this is for frequency modulation, where omega c is the carrier frequency, and this is the message signal corresponding to that angle will vary. So here omega c and the minus of bt by 2, actually bandwidth is entire bt, that is the already has been given in the question, that bandwidth is bt. So masses will have the total variation will have the minus and plus bt by 2, right? So first let's analyze the your output waveform, that is y of t. So 2xt and plus 5xt whole square is there, right? So first term, that is 2xt, if we will find out the spectrum, then the spectrum is centered at omega c and bandwidth is bt. So linear only. In this case, non-linear, your if you'll get it a square, then you can convert cosine function, that is cos square, into the 1 plus cos 2 theta. And in that case, you can find the centered at twice of omega c with bandwidth of the twice of beta t. Just multiply by 2, right here. So in order to recover, the xt using a band pass filter, the spectrum xt must not overlap with the spectrum generated by the xt whole square. So this is the condition only. Now, how can we achieve this condition? So the lower edge xt must be greater than the upper edge of the low frequency message signal component which has less W or near to the DC. So here, like in order to not touch the omega c plus bt by 2 here, this one, and the second harmonic, right? So overlap with the second harmonic, like twice of omega c and minus of bt. Minus of bt, actually minus of twice into bt by 2. So 2 2 will cancel out, and this term will be the minimum in order to keep the zero deviation in between the first harmonic and second harmonic, right? So if you will compile this condition, then you will get the omega c just it should be just greater than 3 by 2 b of t. So as per answer key, your b is correct, right? Okay. So that's all in this session. Thank you to join the session. We'll come with some more questions related to the game. Thank you.